Okay, so check this out. If we graph so you always turn it into an equation. This is a hyperbola because it's minus the x is being subtracted. So we need this to be equal to what on the side? 1. So divide by 36. And so this becomes 4 over 36 becomes 1 over 9. So it's y squared over 9 minus 4x squared over 4, and that equals 1. So we're going to graph that hyperbola. Which way is it going to open? Down. Right, and what's the center, Katie? 32. No. The center is what is, I thought it was square root of the. No, that's your A and B. Center is what's subtracted from X and Y. Yes, you told me what A is and what B is. So the center is here, and you're going to go up how many units in the Y direction? 9. Nope, square root. I want to say 3. 3. 9. 3. And then you're going to the left and to the right 2 units. So you're going to make that little. So A is 9. No. Yeah, A 3 squared is 9. So A is 3. And B squared is 4. So B is 2. So whatever is underneath, you're going to go that many square root of that number in that direction. So you're going up and down 3 units and left and right. So here's my center. Go up 3 and down 3, and from there go to this way 2 and this way 2. 3 and 2, yeah. And these bounce 3 in the Y direction because the 9 is under the Y. And 2 left and right from there. Okay, and then
it is going up and down.
Yes, it's going up and down. Here's your like asymptote, and it's gonna look about like that.
Oh, it looks like that.
Alright. Oh wait, it should have been dotted because
My bad.
I'm sure if you have to throw my eraser.
Right, camera, you're in.
Because it's a strict inequality, that's why it's dotted. You guys all see that?
Oh yeah.
Okay. So you're either gonna shade in both of these sections or outside of them. So let's test a point. What's a good test point? 0. Go back up here. If you take and put 0 in for x and y, what's this whole side going to be?
0.
0. 0 less than 36.
True.
Everything on the outside of both parameters.
Yep. They're not parabolas, but they look like parabolas. So you shade all of that forever and ever.
I don't care that you broke your own.
Okay, now this one, there's going to be a couple here that are going to be a little bit tricky. Okay, nonlinear systems. 2 different methods for finding the solutions here. Actually, not really. When you have, this is the graph of a circle, and this is the graph of a line, and the line is going to intersect the circle in 2 places. So here's what you want to do. You're going to want to solve this second equation for x. So how do you solve that for x? Make sure you're paying close attention to this.
Y equals 0.
No, you want to get rid of the negative 2y. So add 2y. So we have x equals 4 plus 2y. You can't add those terms together because they are not like terms. So you do that, then you're going to substitute that in here. This is probably the hardest type of problem that you're going to have in the whole section. So you solve for x and you're going to put it in for y. You're going to put that in for x. You're going to substitute that in here. Since that's what x is equal to, and we want to find the xy coordinates that are the same, so you put it in here. Oh wait, what is 4 plus 2y, isn't it? 4 plus 2y squared plus, continuing on, that's y squared equals 4. Follow what I just did. We solved for x. X is equal to 4 plus 2y. So I can replace that x in the top one with 4 plus 2y.
And then if you're solving for y, you would solve for y
Yeah, but you'd have to, if you were solving this for y, it would end up being fractions. It's going to be harder to work with.
No, but if it was like y minus 2x.
Yes, exactly. Okay, so when you square something, it means multiply it by itself. So the hard part of this is just because you're going to end up with a quadratic that you got to factor. So you FOIL this, we get 16 plus, what's the outside and the inside going to add to? What's the outside? 4 times 2y. And the inside? 8y. So this becomes 8y and 8y is 16y. And then 4y squared plus y squared equals 4. We have a quadratic. Get everything on one side and combine everything. Yeah, subtract the 4. And I'm going to add these two terms. That's 5y squared plus 16y. And then if you have 16 and you subtract 4, it'll be plus 12. Okay, you can use the quadratic formula, but this is factorable. If you want the quadratic formula, then I will give that to you. You can just ask me. But so it's going to be, it has to be 5y and y, right? And now these have to be multiples. They have to multiply to 12, and they're both going to be plus. You see what? Yeah. Okay, so then your factors of 12 that could go in there are 1 and 12. I think if you have a 16, if I put like a 1 and a 12 in those spots, there's no way.
6 and 2. Wait,
6 and 2. Yes, it is 6 and 2. What would you multiply the 5? We want 16. What would you multiply the 5 by?
2.
2. And then 6.
That's 16.
5 times 2 is 10. Plus 6 is 16. So where would the 2 go so it gets multiplied by the 5?
5y plus 2. 5y plus 6.
Plus
And then y
6.
plus 6. Y plus 2.
Because under the 2.
Yeah, I get it.
So then set each of these equal to 0. And this one would be negative 2. You can do that one in your head, I'm pretty sure. And then this one subtract 6. And negative 6 over 5. Divided by 5. And you get y equals 6/5, negative 6/5, and y equals negative 2. Alright, so there's two different values of y because the original graph was a circle and then the other one is a line. There's going to be 2 places where it intersects. I don't know what the graph of the line looks like, but it's going to be something like that. So we're going to have, we know the y coordinates where it intersects, we got to find the x. Do you guys understand the problem? I mean, do you want me to graph it? That might be helpful. Let's do a quick graph. X squared plus y squared equals 4 is a circle with a radius of what?
2.
So
Right.
the center is 0. So here's the circle, and then the line, if I rewrite that in, well, the x-intercept of that line is 4. I mean, the y-intercept, yeah, the x-intercept is 4. The y-intercept is negative 2. So this is what the line looks like. So we're finding these 2 points right here. So what we're going to do is now we're going to go back to this right here and find the associated x coordinates. Yeah, they're going to. Systems means there's going to be 2 equations, and one of them's going to have a square. The next one's going to be a lot easier, and so is the one after that. This is the hardest type. So you guys, we have x is equal to 4 plus 2y. So how are you going to find the x coordinates associated with this y value? Yep, when y is negative 2, the x is.
Wait, so when you find y, you're not done.
But you're almost done. So you just have to solve for the x coordinate. So this would be 4 minus 4, which is 0. So one point where they intersect would be 0, negative 2. And graphically, that's this point right here. Really bad graph, but hopefully you get the idea. And then the other x coordinate is when y is equal to negative 6/5. And that's going to be a fraction. You can put in your calculator if you want. This would be minus 12 fifths. What's the common denominator? 5. So it'd be multiply by 5. You get 20 over 5 minus 12 over 5, which is 8 over 5. So when x is, so the other ordered pair where they intersect would be the x coordinate is 8 fifths because we were just solving for x, and the y coordinate is negative 6 fifths.
Are we still on the other?
Yeah.
How is that possible?
That's a long problem. I'm telling you, that's definitely the hardest type of problem. But math problems can be.
So, but these two are like the same thing.
This one's gonna be a little easier, and the reason is because you've got an x and a y squared on the top, you've got an x and a y squared on the bottom.
When you only have one x and y ordered pairs.
That's when they're the yeah. Okay, so guys, we have, if you were to graph this top one, do you know what it would be? You have an x squared and a y squared. So it's either circle, ellipse, or hyperbola.
Hyperbola.
That's a hyperbola. And this is a circle.
Yeah.
And so there could be up to 4 intersections. But, okay, so here's what we want to do for this problem. We're going to do the elimination method. So to eliminate, this is a negative 4y squared, and that's a positive 1y squared. If I want to drop out the y squared, what can I multiply this by so that when I add, it'll go away? It won't have to disappear. Multiply this by 4. Very good. So this becomes 16, the top is just the same. 16x squared minus 4y squared equals 64. And the bottom is going to be 4x squared plus 4y squared equals 36. Now add. So this is called the elimination method. You want to get one of the variables to just, you have, but with not squared. Yeah, just with linear functions. So this becomes, what is this? 20x squared. The y term is gone, and then this over here is 100. And then you just solve for x. Katie, stay with me. You got like 20 minutes left. All right, so divide by 20. Divide by 20. Yeah, you might finish early even. And this is 5. Take the square root of both sides, and you're going to do plus or minus. So x is plus or minus the square root of 5. Okay, so then you guys have to also find the y coordinates associated with that. And what you would do is I would take this one, and y squared equals negative x squared plus 9. I'm just subtracting x squared. And then if you put in, I just solved this for y squared. And actually, it'll be easier if we just leave it like this, and then we'll take the square root at the end. So if I put in a positive square root of 5, and I square that, what is that? What's square root of 5 squared? What happens with the square root?
They cancel each other out.
Yeah, so it becomes negative 5. So we have y squared equals negative 5 plus 9.
For a positive?
So y
Yeah.
is one of the y's.
So hold on a second. When x equals positive square root of 5, I put in a positive square root of 5, but I have that negative. So that's confusing. But then you get y squared equals 4, so what is y? Positive, take the square root of both sides. What is y here? Plus or minus 2. So you have these 2 points. Square root of 5, comma 2, and the square root of 5, comma negative 2. And then you'd put in the negative square root of 5. So if you put in the negative square root of 5, you get a double negative, and it becomes 5 square root of 5 squared plus 9. So that's 5 plus 9, which is 14. And you take the square root of both sides, and you get y equals plus or minus the square root of 14. The other two